We want to find the length of this curve, and we can see to take using our formula, we're going to take the derivative dx with respect to y of y cubed over 3 plus, let's pull the 1/4 out and put y to the -1 power. So if we take the derivative, we bring the 3 down, so the 3's cancel, subtract 1, that becomes y squared. Bring the -1 down, that becomes -1/4 y to the -2. Or we can rewrite this as 1/4 y squared. I just brought the negative to the denominator. And so from here we use our formula. So we're going from 1 to 3. Our formula says to do 1 plus, or the square root of 1 plus this derivative that we just found, 4y squared, squared. And so from here, I'm just going to do a bunch of algebra manipulation. So not really doing any calculus yet. So this becomes 1, 3. If I square what's in parentheses, so that's just still 1, I get y to the 4th, because I squared y squared. If you remember, when you square, you do 2 times the 2 values, 1/4y squared. If you don't remember that, I'm just foiling this. So that's the actual middle term. Still got the last term to go. And then I square the last term, which negative and a negative will become a positive, 1/16y to the 4th. Okay, so once again, all this piece was just foiling out that. So from here, I can make things look a little bit better. So you can already see that the 2's, that cancels. Actually, the y squares cancel. So I get 1 plus y to the 4th right there. And then all I have left when I cancel stuff out was -1/2, and then plus 1/16y to the 4th. Now, believe it or not, this actually can factor. Probably looks a little strange, but if I combine those, so let's just do one extra step, and let's go ahead and throw the y to the 4th out front. 1 minus 1/2, so that's going to be plus 1/2, and then plus 1/16y to the 4th dy. The only reason why this seems strange that it'll factor, because your middle piece doesn't have a variable, but remember, if you're doing 2 times that, remember the y squared's canceled. So this actually, if you factored it, factors into y squared plus 1/4y squared squared. Okay, so that is my factoring. And you could square this one out on the bottom, and you would see that you would actually just get 1/2 in the middle. So that part's kind of weird. And so, of course, my dy. And now when I square my square root, I simply have y squared plus 1/4y squared dy. Now I'm ready to find my integral, or my antiderivative. So I'm going to go ahead and rewrite that last piece. So I have y squared. I'm going to pull the 1/4 out front, and I'm going to bring the y to the top, so this way I can see when I'm doing my antiderivative what I'm doing. So y squared becomes y to the 3 over 3, my antiderivative. I have my 1/4 that I just pull out front. My y to the negative 2. Remember, when you're finding antiderivatives, you're adding 1. And so this becomes y cubed over 3 plus 1/4 y to the negative 1 over negative 1, which now I can simply rewrite as y cubed over 3 minus, I'm just bringing that out front, I'm going to bring this to the bottom, 1 over 4y, and I can evaluate it from 1 to 3. So away we go. We have 3 that we're going to evaluate first. 1 over 4 times 3. And then we're going to evaluate 1 minus 1 over 4 times 1. This becomes 27 over 3, which becomes 9 minus 1/12 minus 1/3 minus 1/4, which now I'm going to do that crazy cross multiplying stuff to get my common denominator. So on this side, 9 times 12 is 108 minus that 1 all over the denominator 12. Cross multiply this side, so 4 minus 3, 4 minus 3 over 12. And I get 108 minus 1, 107. Notice I can go ahead and subtract the other one, so I get 106 over 12. And I can actually reduce that by 2 and get my final answer of 53 over 6.